So this is off of last night's homework, the implicit differentiation worksheet here. Remember you started by just finding the derivative of this implicitly. Now, if you compare this to the previous night's worksheet, you'll notice that the previous night was the explicit version of the same equation. So we should see some similarities. So let's take a look. First thing we do, go ahead and find the implicit derivative. So derivative of x cubed, you do that just like normal, remember. X still works the same. But when we find the derivative of y cubed, remember that you're using chain rule there. So you got the function y that's being cubed. And so derivative of the outer, and then times the derivative of the inner, which is just the y prime then. Now, if anything was tripping you up here, actually what most people got tripped up by of something was actually the 125. Remember, if it's a constant, derivative is just 0. All right, from here, solve for y. So we subtract the 3x squared from both sides. Then go ahead and divide both sides by the 3y squared. And then finally reduce it. Did you remember to reduce it?
No. Yeah.
Yes.
The whole thing comes down to just y prime equals a negative x squared over y squared. Now, one little variation on this though. Now that we have a correct version of this, I want all of your correct implicit derivatives to all be sitting in one place. So, take out your implicit graphs that you made on Tuesday.
Oh, no.
This is the very first equation that you graphed there. Please write this derivative and its work below that. I'll give you a minute here. The other problem you did on last night's homework was this one, and you found this derivative. I think you probably got a nice idea about what the rhythm is like. So go ahead and check all the work right here. You should have found that y prime equaled a negative x over y.
Yeah.
So also write that work, please, on your implicit graphs 1 worksheet. All right, so this equation, this is the next equation out of the implicit graphs worksheet, so that's where we're doing our work there. You'll notice on your graph passes through the point 10, 3. That's why that's chosen, because it's actually a point that's on the graph. And any point that's given, yes, actually has to be a point that's on the graph someplace. All right. First step, since we're looking for the tangent, we need to find the derivative. And in this case, notice that we have it written implicitly. We have y in there and we have x in there. It's not solved to be y equals or x equals. So, find the derivative implicitly. That means we do the derivative of y, which is y prime, plus the derivative of y squared. What is the derivative of y squared though? Think it through.
Y prime.
Yeah, good. 2y prime. We got to remember that we got that y prime in there because we're using chain rule, where we're doing the derivative of the inner function and the derivative of the outer function there. All right. From there, we do the derivative on the right side. What's the derivative of 2? 0. So that's gone now. What's the derivative of x? 1. So the entire right side is 1. Now from here, we still need to solve this for y prime. So now solve this equation for y prime, please. So remember, in order to solve this for y prime, we're going to have to factor out the y prime. So y prime times 1 plus 2y equals 1. Now to solve for y prime, we can go ahead and divide both sides by all of that stuff that's in the parentheses. So y prime equals 1 over 1 plus 2y. All right, we now know what y prime is. But remember, that's not where we stop in this particular problem, because we're looking for the tangent at 10, 3. So what are we going to do next?
Plug in 3.
We're plugging in. It's just before, when we dealt with explicit derivatives, we'd be plugging in for x, because our equations always were in terms of x. In this case, there is no x. There's only a y. So we're going to plug the y coordinate in for y in this equation.
Why would you do this?
So y prime equals 1 over 1 plus 2 times 3. Simplify from there. You should find that y equals 1/7.
Is that still the same?
Now, y prime, it means derivative. Derivative still means slope of the tangent line. So this is it. That is your final answer. That is the slope of your tangent. All right, next problem. This is not the next equation on the implicit graph sheet, but it is one that I think you can go ahead and do on your own from here, at least up to a point. There's one little thing that's going to give you a little twist, but I want you to get there first. So go ahead and work this one through. All right, now the beautiful thing about this problem is it should still look familiar, right?
Oh my gosh, do we have to find the...
We did this derivative on last night's assignment. We also started class today with it. We already know that y prime equals a negative x over y. We found that earlier. And so we can now go ahead and use this. So we want to know the slope of the tangent at x equals 3. Well, that means I'd plug 3 in for x, right? But what about the y?
You're supposed to find it. No, you have to find it, right? Because...
You have two options about how to proceed. Option 1. Plug x equals 3 into the original equation, so you'd be plugging it up here, and you can figure out what the y coordinate is that way. Option 2, you can solve this original equation for y, make it y equals, and then you can plug what y equals in for y down here. Both work. Pick one, either one as you're choosing right now, and go ahead and do it from there, and then I'll illustrate how to do it both ways after you've had a chance to work it through. Now, most people, when you start going through this, most people end up choosing option 1 because it sounds like it's a lot easier. And in some ways, maybe it is. If you're doing it that way, you're going to do 3 squared plus y squared equals 49, and you're going to solve that through. You end up getting y squared equals 40, and then you got to take the square root of both sides. But when you take the square root of both sides, what do you need to remember? Plus or minus. So here, y would equal plus or minus root 40. Or if you want to get extra fancy, 2 root 10.
Oh, plus or minus 2.
Yeah. All right, now that I know what y is, I then could go ahead and use that. So I could find my slope by doing y prime equals a negative x is 3 over plus or minus root 40. That plus or minus is kind of awkward sitting in the middle there, right? If I apply that negative to the plus, it gives me a negative, right? If I apply that negative to the minus, that gives me a positive. And so then it'll actually work out to be y prime equals plus or minus 3 over root 40. And so there's our slope. And that's one way to find it. Now, I also want to go through the other way, though, because I want you to see at least that it's possible. Even if you don't choose to use it for this one, I want you to know that this is possible. So, in this case, we solve the original equation for y, but this time we're not plugging in 3. We're just solving it for y. So that would be y squared equals 49 minus x squared. And then y would equal plus or minus again, square root of 49 minus x squared.
How will we know what x is?
Well, I now can substitute this value for y back into my derivative equation. So I now know then that y prime would equal negative x over plus or minus square root 49 minus x squared. Or you can again take that plus or minus out front. In fact, I'll just go ahead and move that now. And so we have that. And now you could plug the 3 into this and get the same thing. But notice in this case, you're only plugging in the 3. You didn't have to go do a separate operation. You have one equation to use. Which method is better? Well, if you are just asked a problem like this where you're given all of this information and then the x-coordinate, and this is the only one you're going to have to do, the top one probably seems easier for most of you. And if so, that's fine. But if I was going to say, what is the tangent at x equals 3, 4, and 5? It'd be a lot easier to just have a single equation that you could plug into. And so then you'd want to use that. Now, one last thing on this problem. Notice our answer has this plus or minus in it. Look at your graph for that one. Where x equals 3. Where is the graph? It's at two different places, right? And you notice one of them has a positive slope and the other one has a negative slope. And so it's actually giving us both of those slopes because all we knew was that x equals 3. We didn't know which y coordinate we were supposed to go to in this case.